All right, today we're going to talk about the rectangular coordinate system to start off chapter 3, but to kind of transition into it, let's recap a little bit of chapter 2 and solving equations and how it's going to relate here. In chapter 2, we answered a question like this. Three equals x plus 2. All right, so this is a relatively easy one. We can see that the answer is x equals 1. All right, and a key thing here that's going to differentiate between chapter 2 and chapter 3 is that there's only one solution. I know 1 is the only number that's going to work in this equation. So there's only one solution. All right, chapter 3, we're going to adjust this problem slightly, and instead of one variable, just x, right, now I'm going to have two variables, an x and a y. So I'm going to change this equation to something like y equals x plus 2. In chapter 3, we're going to be looking for solutions to this type of equation with two variables. All right, remember, a solution is still, it's just a value for x and a value for y that's going to make this statement true. So we need x and y, right, to make a true statement. So one way to keep track of our x's and y's, we do it in a little chart. So each solution to this equation is we can fit in this chart with an x value and a y value. So I'll just make up a few quick solutions to this, and if you want to try on your own, I try to add some other solutions to this. All right, we can use the solution that we had up above. If x equals 1 and y equals 3, okay, then we have a solution, and I'll just show you it out over here. So if y equals 3 and we substitute it in, we have 3 equals x equals 1, and we substituted in 1 plus 2. All right, so now we can see that this statement, 3 equals 3, all right, that's a true statement. So this would be considered a solution to this equation. All right, we can come up with other ones, though. That's not the only solution. Let's see, if x is -1, right, then we would have, if we substitute -1 in for x, we would have -1 plus 2. All right, well, what y value would we need in order for this to be a true statement? Well, -1 plus 2, that should be 1. So if we put a 1 here, now we have a true statement, which would mean the y value that we need is 1. So this pair creates a solution here. And we can find one more. I'm going to let y equal 0 this time. So notice now I'm going to pick a value for y. We can start with a value for x or a value for y, and we can just substitute it in. So if I substitute 0 in for y, we have 0 equals x plus 2. All right, so now we have an equation. We're not quite done in this case because I still need to find out the x value that would go with it. So we can solve for x. We can subtract 2 from both sides, and we can find out that x is equal to -2. So the correct x value here will be -2. So here's 3 solutions. Go ahead and try to find a couple more if you'd like, just by picking values, or maybe you can just look at the equation and find an x value and a y value that would match up. Right? So key thing to notice here that's distinct from chapter 2 is we can make this list go on forever. So there's actually an infinite amount of solutions. All right, so keep that in mind and keep this example handy because we're going to come back to it in a second. Okay, so, all right, let's talk about these solutions. We know there's an infinite amount of them, right, but we don't always write them in a table. There's another more convenient way to write them. So we write our solutions as ordered You may be familiar with this notation. It's just a set of parentheses with an x first and a y second. So this is considered our x coordinate. And this guy is considered our y coordinate. And this will always be the case. Our x coordinate always comes first. Our y coordinate always comes second when we're dealing with an ordered pair. Okay? And some people would just call this a point. Okay? And it's called a point, or we reference it as a point because once we have this solution, we can plot it on the rectangular coordinate system. So this is something you may have seen before. If we have an x value and a y value, I need a number line to represent the x, a number line to represent the y's, and we do that here. We have an x-axis and a y-axis. And right in the center, we call the center the origin. But it's right in the center of the x-axis and the y-axis. So for our coordinates, it has a coordinate of 0, 0, right in the center. And as we go to the right, that's the positive direction. So 1, 2, 3, 4, 5. We can make 5 spaces to the right. As we go to the left, this would be the negative direction. So 1, 2, 3, 4, 5. Negative 5 out left. As we travel up the y-axis, this is the positive direction, positive 5, and as we travel down the y-axis, this is the negative direction. So now we have both number lines scoped out. So now let's revisit our solutions over here to this linear equation. So I'm going to write these all in ordered pair format. So we have our solutions. Again, I'll write up here. 1, 3, negative 1, 1, and negative 2, 0. So I just took these three solutions from over here and wrote them in here. If you came up with some more solutions, feel free to add them, because now we're going to want to put them on a graph. So if we're going to want to plot a point, the point 1, 3, that's an x value of 1 and a y value of 3. So we can go on the x-axis to where x is 1, go on the y-axis to where y is 3, and it's going to be where those two spaces converge. So they're going to converge right up here. Here's where our first point is located. That's our solution. So that's the point 1, 3. We also have the point, or the solution, negative 1, 1. So this is negative 1 on the x-axis. Positive 1 on the y-axis. So those 2 points are going to collide there to create 1 point, negative 1, 1. And then lastly, we have x is negative 2, negative 1, negative 2. So let me readjust this a little bit. So negative 2 on the x-axis. And 0 on the y-axis would mean we don't go up or down at all. So this point right here will be our negative 2, 0 point. So what you can notice now, if your graph is to scale and not all wacky in terms of going right and left, and you have even spaces in between, these three solutions that you came up with, and even if you came up with more, all the solutions you would come up with, if you connected the dots, should create a straight line. And this line what it does is it represents every single solution to the equation over here, y equals x plus 2. So that's what I'll put down here. So we found 3 solutions, but if you were to find any other points on this line, they would also be solutions to the line y equals x plus 2. So this line is a solution to, this line, that is a solution. It represents all of the solutions. Let me correct that. This line represents all these solutions to y equals x plus 2. All right, so just to show you, all right, one last thing quickly, all right, to show you what I mean by that. If we find any other point along this line, so I'll identify one other point that this line goes through. It looks like it goes right through this point we can find. So another good skill to have is to say, okay, if we have this point on the line, what are the coordinates of this point? So if we want to find the coordinates, I need an x value and a y value. So in terms of the x value, right, I'm right in the center of the x-axis, so my x value should be 0. Right, and on the y-axis, I'm up 2. So this would be the coordinates 0, 2. Right, that's my x and my y again. Right, so if we take this point that's on the line and we substitute it into our equation down here for x and for y, does it create a true statement? Let's take a look. Right, x is 0, and y is 2. Right, and there we have it, 2 equals 0 plus 2. That's a true statement as well. So hopefully that's convincing enough, right, that no matter what point you found on this line, right, those coordinates, when substituted into this equation, would create another solution. And just as a side note, these 2 points that we have on this graph, this guy right here has a special name, and this guy right down here has a special name. And we'll revisit these in the next section, but right at the point where your line crosses the y-axis, this is called the y-intercept. And the point where this crosses the x-axis is called the x-intercept. Right. So we'll pick this back up in 3.2.